Okay, right, so B2 is a DCG Mocks 2022. We have tetrahedrons, okay, that are made out of four-sided equilateral triangles. Draw the projections of both tetrahedrons. Scale is 1 to 200. So basically convert meters into millimeters, okay, and when you divide by 200, that knocks 2 noughts off, okay, and you're left with 2, 8 divided by 2 is 40. So basically half every number add a naught on. Okay, it's a good idea to put them in. Okay, write them on the sheet. Okay, so XY line. The question is based on intersecting solids. So XY line. Sorry about the flicker there in the video. Right. Big tetrahedron, edge length of 100 millimeters. Okay, we can draw it in as a heavy line. Okay, 30 degrees here. 30 degrees, I'm going to start this as light because we don't know where to heavy it yet. Okay, we can project our lines up vertical for the tetrahedron in elevation. And then we can heavy in that one as there's going to be no intersection there. Okay, now we don't have the height of the tetrahedron in elevation. What we do need to know is that this line is parallel to the XY line, so it's the true length in elevation. So if I get my compass, set it to the length of the base, because the base is the true length, swing an arc in elevation, and then this is the apex of the tetrahedron in elevation. Right, and we can mark that in, and then we'll lightly connect this here, because we have to find out where the parabolic tunnel hits the tetrahedron. Now that was, sorry you missed that in the video, so I swung an arc there 100, went up from the apex until they intersected. Now the plan view, so the next tetrahedron starts 2 centimeters from the apex of the big one. Okay, the question is, what's the size of the edge length of the tetrahedron in plan view? Okay, so working backwards from what you were taught here, this was the true length. Over here they give you the true length here, so the edge of the tetrahedron, okay, is the same value as that. So the size is 80. So 40 up, 40 down. It's going to be a light line. So 30 degrees there. Okay, and then you can heavy that one in. Parabola is never going to intersect that. Heavy that in. Right, then we're bisecting the angles. You can heavy these in too. You can actually get a bit of a hint by the lines in plan on the question when they're thicker than the thin ones. Now I'm going to project the apex of the tetrahedron up to elevation. Here and here. I'm going to set my compass to a radius of 80 millimeters, and I'm going to swing an arc then in elevation. Where that intersects there is the apex of the smaller tetrahedron, and then we can draw in a surface or the parabolic tunnel S. The height of it, okay, is 40 as per the end elevation. Height of it is 40. So we can draw that in lightly. Now, in plan view, if we check the end elevation, so the width of it is 12 meters, 60 millimeters, so 30 and 30. So there we go. Right. Now, Draw the parabola ABC in end elevation. Okay, we'll complete our elevation first. Right, so YY line, 45-degree line here. Now we can project across. Now we can project these points up to complete our end elevation, and then we're going to draw the parabola in end elevation using the rectangle method. Okay, we'll project across from elevation. Now, here's the apexes of the tetrahedrons. Okay, here's obviously the edge of the big one, so I can heavy that in. Okay, here's the other one. Okay, smaller one next. Now, and then a heavy line downwards as the parabola is in between them. Okay, now the parabola, right? So this is the apex of the parabola here. Okay, this is an end point of it. So we're going to use the rectangle method to construct the parabola here. So divide the base in 3 equal parts, because it's 30 and 30 divides evenly by 3. Simple number to use. Okay, construction lines up then. Okay, now divide the side of it, okay, into 3 equal parts as well. So it's 8 meters tall, 40 millimeters. 40 divided by 3 does not go in equally. So we're going to draw a line at any acute angle. Okay, and we're going to mark 3 equal dimensions on that. So I'm going to mark a line, okay, 30 millimeters long, and mark 3 10 millimeter increments on it. Now I'm going to draw in the last point, okay, to the top here with my set squares. I'll slide my set squares parallel. There. Now I can join the first one back to V here, okay, the vertex, and the second one back there. Right, label these. So 0, 1, 2, 1, 2. Here's a point in the parabola, and another point there. Now we can mirror them across. Okay, you don't even need to use your compass. Okay, they're going to be 10 across from the center, and then 20, and then obviously 30 here. So we can freehand sketch those points in. And then we're marking the hidden detail there at the end. Right, so we need to draw, okay, complete the drawing by showing where the parabolic tunnel intersects the tetrahedrons in plan and elevation. I'm going to label these points A, okay, B, I'm going to label that V for vertex, C, D, okay, and then I'll leave that as 0, okay, and I'll call this point 6. So, point 6, okay, let's get the easy ones, right? 0 and 6 in plan and elevation are easy to get. They're on the bases of each tetrahedron. So, here's, there's 6, and there's 0. Alright, so 0 and 6. and then in elevation 6 and 0 is there, and then on the other side I'll just call these the same. Okay, 6 and 0, and to get them in elevation they're obviously straight up. (6/0). Right, now, great thing about this is that this surface on the tetrahedron, okay, here, projects as an edge view in elevation. That's brilliant when that happens, because it's much easier to find, right? Apex here. Here's the apex. So points, okay, D and C, okay, in elevation stop right when they hit the edge view of this surface. So I'm going to bring across C and D. And here's point V, vertex. I'm going to bring across C and D. So there's a point view of C and B. D and A I'm going to bring across as well, so D/A. Now if I want to get them in plan, right, I can just drop V down, so down across from V, that's in the center. C and B I can drop down, D and A I can drop down. Okay, now so I can drop the points down here from end elevation, okay, to plan view. They're essentially increments of 10 from the center line in plan and elevation. Right, so this is going to find me point D. Okay, this is going to find me point C. And then on the other side, this is going to find me point B. So point B is just found there, point A, and there's 0. And then you can freehand sketch them in. So there's the lines of intersection in plan. And then we have to get them where they hit the other tetrahedron, which is a bit harder now. Alright? So what we're essentially going to do is draw horizontal sections in elevation, where if you draw a horizontal line, or in elevation and end elevation, you're essentially slicing the pyramid across. I'm going to draw a horizontal line, which you've already done, through, okay, the points in elevation. Now, these orange, okay, lines in end elevation represent a triangle in plan view. It's a section of the tetrahedron, and it's another equilateral triangle smaller than the original base of the plan. So I'm going to drop the end of this orange line down to plan, or to the 45-degree line, and I'm going to bring it back until it hits this edge of the tetrahedron, because this is apex and 7, 8, okay, line 7/8 there. There's the apex. Okay, I'm going to call that M. So here's letter M there on that line, because that's apex as point 7. Now, so I'm going to get now a triangle that's smaller than the original plan view. And line D, or point D, rests on this triangle. So I can follow D down and across. There's point D. Okay, same concept with C now. So I'm going to drop or draw the horizontal line through C and B, and I'm going to bring it across here until it hits line apex to 7, and I'm going to draw in an equilateral triangle that's smaller than the plan, and this contains letter C and B. So I'm going to cross there for letter C. Okay, for letter B, across, there's letter B. Okay, I'll go back to D there, letter A. There's letter A. And then for Z, there's 0. Okay, and there's 6. And then letter V then. So I can draw a horizontal line through V. Okay, I can drop the line down. Across then. Let's draw parallel there. Don't need to do it all really. Okay, V. You know, once you know that much, you're away there. Right, so that's letter V. Now we can heavy them together there. So D, C, V, V to B, B to B, A, 0. Okay, there's the intersection lines in plan, and then you can heavy in the detail there on the tetrahedron. Sorry, I picked up my 2B pencil by mistake. Can't be at that shenanigans. Okay, we need to find those points in elevation now. Okay, so it's fairly straightforward then to find them in elevation. We're just going to project the points upwards. So V, right up to it there now. So this is where point V is. See, the 2B pencil got me off a little bit on it. So there's V. Sorry. There it is. There. Now C and B. So C slash B. Okay. D and A. So D slash A. Now I'm going to freehand sketch these in as well. Okay, there's that there in elevation. And that's that in plan, and I have to put in my hidden detail there. Right, so that's the question complete. I will show you, if you want to continue watching, I will show you an alternative method of finding the lines of intersection in plan, in plan. So what you could do, right, is you could look along the base of that tetrahedron. Okay, and that base is on the XY line elevation, so it's the true length in plan. So you're going to get the elevation projecting as, or you're going to get the surface, okay, of the tetrahedron projecting as an edge view. So I could take the height of the apex, obviously, from my elevation. Take the height, okay, plot it up to there. So that's an edge view, okay, of the surface there. Now, I could take the height of A, okay, and B, plot it there, B and C, plot it there, and V, okay, plot it there, and then I could bring these lines, okay, in until they just hit the edge view of the surface, and then I could project these. You could project these back down. So this would be V, this would be C, okay, and this would be D, and this would be 6. So that gets, and then you could project them back down then to there until they intersect the point going down across. That's an alternative way to do it, to get to certain, because you're getting the face, it's contained on as an edge view, and then to get the other side, well, you could repeat the same thing or just flip them around. The more accurate way really will be horizontal sections, because there's no mirroring around. Right, thank you, cheers, bye bye.